Hello students, welcome to module 2, bistables. Here the name bi means two. There are two stable states. In binary, the two stable states are either 0 or 1. In digital electronics, this 0 is called as the reset and this 1 is called as set. Usually whenever we say 1, we say the circuit is in set state, and when the output is 0, we say the digital electronic circuit is in reset state. So bistable means there are two stable state, either logic 0 or logic 1. Remember, logic 1 is called as a set state, logic 0 is called as the reset state. A bistable circuit can be used as a memory cell because it will be in the set state or in the reset state. Suppose if it is in the set state, it remains in the set state until you change the inputs so that it goes to the reset state. Then it will be in the reset state only till you change the inputs to make the bistable to set it. So this is the set state and this is the reset state. So bistable constitutes a simple form of memory cell. The application of this bistable is you can use it as a memory cell because it will remain in its latched state. What do you mean by latched? It will remain in the particular state unless you change the inputs to change the output. So it will be the stable state. It will be the 0 only. If you change the inputs, definitely it will change the output and it will retain the same state until you change the inputs. So it is a stable. There are two stable states, so it is a bistable. The two stable states are logic 0 and logic 1, and it will have the latched state whether set or reset. Until a signal is applied to it in order to change its state, it will remain in the same state only. In this video, let us discuss the RS bistable. The R stands for reset, S stands for set. So whenever you hear set, remember it is 1. Whenever you hear it is reset, just remember 0. Reset means 0, set means 1. RS bistable. This is the most simplest form of the bistable. In some textbook, it is also called as SR bistable. Nothing to worry. S stands for set, R stands for reset. So RS bistable or SR bistable, they are one and the same. Here there are two inputs. One is set, the other one is reset. S stands for set, R stands for reset. And we have the complementary outputs Q and Q bar. Q and Q bar. Here is Q, here is Q bar. These are the complementary outputs. A logic 1 applied to the set, will cause the Q output to become logic 1. Q will become 1 if set is equal to 1. So this is a complementary, Q bar is complementary, so it becomes 0. Suppose if you apply reset is equal to 1, set is equal to 0, so Q becomes 0 and Q bar becomes 1. So this RS bistable can be constructed using either NOR gates or NAND gates. So let us discuss this NAND gate RS bistable. Before going to the analysis, let us recall the NAND gate truth table. NAND gate truth table, if you remember, so we had two inputs AB and one output, let us say Y. So we had four combinations 0 0, 0 1, 1 0 and 1 1. It is NAND gate 0 and 0 is 0, 0 complement is 1, 0 and 1 is 0, 0 complement is 1, 1 and 0 is 0, 0 complement is 1, the last one 1 and 1 is 1, complement is 0. So this is the truth table of the NAND gate. Just observe the NAND gate truth table. Here, if any one of the input is 0, if any one of the input is 0, the output becomes 1 irrespective of the other input. Don't worry about the other input. If any one of the input is 0, if any one of the input is 0, output becomes 1. Only the output is 0 only when both the inputs are high. So we will use this to analyze the RS bistable using the NAND gate. So we will have the 4 combinations of the inputs. So I will write AS, R, then Q bar. Initially, I will apply S is equal to 1, R is equal to 0. S is equal to 1, R is equal to 0. Just now we learnt any one of the input is 0, the output is 1. Any one of the input is 0, don't worry about the other input, just the output changes to 1. So here the output Q becomes 1. Here then this 1 comes here. So for this NAND gate, both the inputs are high, 1, 1, output becomes 0. So Q is equal to 1, Q bar is equal to 0. As we discussed earlier, if Q is equal to 1, then this state is called as the set state. So whenever you want to set the bistable, make S is equal to 1, make the set input 1, reset input 0. So this is the first case. Now let us change S is equal to 0, R is equal to 1. Concentrate on the green mark. Set is equal to 0, reset is equal to 1. Any one of the input is 0, the output is 1. So 0 changes to 1. This 1 comes here. So 1 and 1, it is complement of the AND. So 1 and 1, the output is 0. It changes to 0. Now Q is equal to 0, Q bar is equal to 1. When Q is equal to 0, it is called as the reset. When Q is equal to 0, it is called as the reset. So these are the 2 states which are there in your syllabus. S is equal to 1, R is equal to 0, it is set. S is equal to 0, R is equal to 1, that is my intention is to reset it. So reset means Q is equal to 0. Definitely another output, it is complementary of the Q, so it becomes 1. So set and reset. Let us try with making both the inputs 1, 1. S is equal to 1, R is equal to 1. S is equal to 1, R is equal to 1. Now the previous state was 1. So this one comes here. 1 and 1. Complement of that is 0. It retains the 0 state. This 0 comes here. This 0 comes here. 0 and 1 is 0. 0 complement is 1. So there is no change in the output. It retains the same state. So 1, 1. So here we can write it as it retains, or there is no change. Here there is no change. There is no change. Then most critical, we have 4 combinations. I think you have understood. S is equal to 1, R is equal to 0 set. S is equal to 0, R is equal to 1 reset. If it is 1, 1, there will be no change. It will be in the previous state only. There will be no change in the output. But the curiosity arises, what happens when reset is equal to 0, set is equal to 0. We will try that. I will use different color. So when reset is equal to 0, set is equal to 0. As we know, any one of the input is 0, the output is 1. Here input is 0, output is 1. Input is 0, output is 1. Q is equal to 1, Q bar is equal to 1. It is against the complementary role. Q and Q bar are complementary to each other. So this S is equal to 0 and R is equal to 0. We call it as a forbidden state, illegal state. It is not used in the RS bistable using the NAND gates. I think this is clear for you, the RS bistable using the NAND gates. Now let us move on to the same RS bistable but using NOR gates. So for that we need the NOR gate truth table. So let us write the NOR gate truth table. NOR gate, it is the NOT of OR gate. So 0 plus 0, 0, 0 bar is 1, 0 plus 1 is 1, 1 complement is 0, 1 or 0 is 1, complement is 0, 1 or 1, it is 1, 1 complement is 0. So this is the truth table of the NOR gate. If you observe here, any one of the input is 1, any one of the input is 1, the output is 0 irrespective of the other input. So let us use this. Now once again we will write the truth table for the SR bistable using NOR gate. Initially I will make S is equal to 1, R is equal to 0. S is equal to 1, R is equal to 0. Any one of the input is 0. If any one of the input is 0, if any one of the input is 1, the output is 0. So S is 1, so output becomes 0. So this 0 comes here. 0 plus 0, 0, 0 complement is 1. So Q becomes 1, Q bar becomes 0. This state is called as a set state. This state is called as a set state because my intention was to reset, because S is equal to 1, R is equal to 0. Suppose here let us change a little bit. We will apply S is equal to 0, R is equal to 0. S is equal to 0, R is equal to 0. Concentrate on only the green color inputs. S is equal to 0, R is equal to 0. Here one of the input is 0, the other input is the feedback signal. The output of the first NOR gate comes here, that is 1. 0 or 1 is 1, 1 complement is 0. Same. The 0 comes here, 0 or 0, 0, 0 complement is 1. So there is no change at all. There is no change at all. Here it retains the same state if S is equal to 0, R is equal to 0. There will be no change in the output. It maintains the same state in the RS bistable using NOR gates. Suppose if S is equal to 0, R is equal to 1. Concentrate on only blue inputs. S is equal to 0, R is equal to 1. Any one of the input is 1, the output is 0. So here input is 1. So this changes to 0. This 0 comes here. 0 plus 0, 0, 0 complement is 1. Now Q becomes 0, Q bar becomes 1. This state is called as a reset state because S is equal to 0, R is equal to 1. R is equal to 1 means our intention is to reset it. So earlier it was set, now it has changed to reset. If it is in the reset state, it maintains the same reset state. Otherwise, it changes from set to reset. So our intention is to reset it. Now let us go for the last state, that is 1, 1. So S is equal to 1, R is equal to 1. Any one of the input is 1, the output is 0. So here it becomes 0, here it becomes 0. Q is equal to 0, Q bar is equal to 0. It is against the complementary rule. So this state is called as the forbidden state. So we are not supposed to apply S is equal to 0, S is equal to 1 and R is equal to 1 and the NOR gate RS bistable. So this is a simple RS bistable used as a memory. We can save 1 or 0, a 1-bit memory. So I hope you have understood. In the next video, let us discuss the D bistable. Thank you.